So we are just about. So we are just about to start the next session, session number 5, and I just would like to have your attention for a minute. So before we start the session, I just have one wish, and this is for those colleagues who will participate at the capacity training on Thursday and Friday. So you need access to the SDMX lab. And at the moment we see that from the 140 people which participate in on the first day, only 30 have actually registered for the SDMX lab. So in order to avoid a logistical nightmare on that day, can you please have a look in your emails and follow the instructions in your email to get access to the SDMX lab. If you have a problem with setting up your account there, in the coffee break, there is the HMS booth. You can go to the colleagues and you can ask for help there. But please try to spend some time now in order to get access, because tomorrow it's going to be a little bit hectic in the morning. All right? So this is for those people who attend the capacity training on Thursday, Friday. Please get your account for the SDMX lab. Thank you. And with this, I hand over to Olivier.
Thank you very much. We have this afternoon another very packed session. We have 8 presentations and we have 85 minutes for that. So we will try to be as efficient as the previous session. So I would ask all the presenters to stick to the 10 minutes, and we have someone to keep us on track on this. So this session is about improving statistical business process using SDMX. In one of the side session or side meetings we had, someone mentioned that the X in SDMX should disappear. X, what was there because SDMX was basically a standard intended to facilitate the reporting by some agencies to some other agencies of statistical data. I think it's obvious to absolutely everyone that it is much, much more than that, and that the beauty of SDMX is now in every process of most organizations that have decided to use the SDMX. So what we're going to see this afternoon is another series of examples where SDMX has been embedded in different processes of quality control, of improving automation, making data ready, building better service for the users. So this is a very good continuation of all the nice examples we had so far today. So I'm not going to speak much today. I'm not going to try to summarize every presentation. They are very diverse. And I don't want to steal time from the presenters. So without further ado, we'll start with Sujesh Kumar from the Reserve Bank of India, who is going to make a presentation on a pilot initiative for element-based reporting in the Indian banking sector. So Sujesh, the floor is yours.
Thank you. Very good afternoon for all. First of all, let me express my sincere thanks to the organizers for this SDMX Global Conference. And I'm thanking the organizers for giving this opportunity, this platform to present our SDMX journey in the Indian banking sector. So let me start with the overview of the SDMX, or overview of the data management in the Reserve Bank, and what are the SDMS initiatives in the RBI, and the conversion tool what we have used for converting the traditional data into the XDMX data formats, and the XDMX collection initiatives. This is a pilot initiative. This basically I am focusing on this, and how we executed the pilot plan and what are the developments so far. So this is what I'm covering in my presentation. Let me come to the overview of our system. As a regulator of as a central bank of the country, as a regulator, we are regulating around 11,000 regulated entities across the country. And we have a specific template called the return. We call it as a return. This is a statistical format in which we collect the data. And this is something around the 240. And we collect different types of data like supervisory data, regulatory data, and payment system data, macroeconomic data, not only from the regulated entities, it is from the other organizations also. And survey, of course, survey statistics. We collect and disseminate this type of data. And we also use various channels of collection data. There is a system-to-system channel. This is fully automated channel. There is no manual intervention. And second one is the file upload channel and screen-based channel. This is another channel through which the entity can submit the data, because in Indian case, because the number of entities are more, the maturity, IT maturity is not similar to all the entities. So we are given different choices. Accordingly, they can submit the data. And we also maintaining our neighboring countries' SAC database. So all the macroeconomic data we are maintaining, so that even other country data also for the researchers and those who are using the data, they can download the data. This facility we are giving through our data portal. And very extensively we use the data based on Indian economy. This is the macro level data we disseminated through the system. It is called a DBI. It is well known in India because all the researchers, universities, all the data organizations, data of service providers, everybody using this data. And almost 1,000 plus reports we are releasing, around 2 lakh data series, and this sector-wide dissemination. And coming to the XDMX, we have started this journey for the last 3 years. In 2022, there was an internal committee set up by the Reserve Bank of India to how to reduce the reporting burden of the regulated entities. In that aspects, out of several recommendations, one of the recommendations was you should use the element, you should explore the element-based reporting, and it should be a future vehicle for the data collection from the regulated entities. Here the element, you should not be confused, the element is in the XDMX language, it is the DST. Basically, it's a DST. So we have started this journey in 2023, and we created the data elements based on the business purpose. Because, as I said, there are 243 returns currently, it is applicable. Currently, banks are submitted. We examined all the data sheets, and we identify the dimensions, code lists, everything is coded, and it's such a laborious exercise because the 240 in each, the number of cells are much, much higher because we are collecting large volume of data. So that exercise we have started, and we have created an element-based repository, and then we have developed a SDMX-based tool. This is a data query tool, so that everything is metadata driven because we already defined the metadata for each and every dimension. It is so from that metadata hub, so anybody can query that facility. We are made available in the RBI portal. So this is some of the overview about our. This is just a flower of our. This is a cross-section view of the return. So we have defined around 1,100 DSDs. We have defined around 1,400 dimensions. We have defined. And in the central we have SDMX Manager, and we integrated with the Fusion Metadata Registry. And data query engine also we developed, and the converter tool, because we have to parallelly convert from the return-based information to the element-based data. This is one level of conversion. And we also developed a converter tool for the banks, because we need to fulfill certain prerequisites, because in the journey of SDMX, it's not only the data elements we ourselves created, but in the banking sector also they have to adopt our standards, because we define the standard for the SDMX, and we advise the bank, you also follow the same set of standards, so that they will also have to create kind of data repository that will be easy to communicate with us. So in the data query, there are different segment, the way we are disseminating the data in the database of Indian economy. This is a sector-wise, a corporate sector data, or financial sector data, and real sector data, public finance. These are the broad categories, so in which people can simply click and download the data. This is already available, but in the XDMX format also we have made available. You can simply you can plug and play around the dimensions and code lists. Finally, we can even produce the beautiful charts and the different types of chart. We can combine multiple dimensions, join graphs, all we can produce. And we integrated with the Fusion Metadata Registry. It is available in our website. And anybody want to see, the link is given here. So this another tool what we have developed for the bank. So from the bank side, they have to create a data level element repository. From the repository, the tool will pick up the data using the, convert the data from the granular. Actually, there is an infrastructure is already put in place because we are given guidelines to the banks in 2019. There is a server, the automated data flow server. So the granular level data will be captured in that server, and then automatically data has to flow to the next level. So there we have given the standardization. Accordingly, they created their repository, and then they convert to XML. Then next step, it will be filed either through the system or through the manual filing. So this is the facility we are given to the banks. And we have started these projects, it's a collection perspective because the dissemination level we already achieved because the journey we started from 2023, 24, and 25, we have achieved the data. All the macroeconomic data we are converting to XDMX format is available for dissemination, is already available. Now the XDMX-based data collection, that is what I was referring. So you started a pilot project in the 2024 we were initiated, and with the start, we started with the 4 regulatory entities, and there are, SDMX is the backbone for this transition. And ultimately, it should improve the overall efficiency of the reporting entities and the regulated by reducing the reporting burden. This is one of the objective of the element-based reporting by adopting the SDMX as a tool. And it will provide a foundation for the RBI to build more data quality framework because there are different dimensions, as you know, the data quality. So we can even access the data quality of the data, improve the overall efficiency. So this is the overall intention of Reserve Bank. And so this is the high-level architecture. We are providing the metadata to the banks, and bank has supposed to generate their SDMX data flow, and they are transmitting to the RBI data warehouse, and we are processing, and we are given a generating report. There are 2 sets of, we disseminate internal data and for the public. So all these are happening through the centralized information management system. I forgot to inform you because there is a system we recently developed in the year 2024. We inaugurated this new system because it's an integrated platform for the data collection, data dissemination, data processing. So everything in a single system. So we integrated everything and put it together. We call it a centralized information management system. Yeah, it's already mentioned. This is a SDMX manager. This is the central hub, and from there we metadata hub, and we defined all the metadata, and this including data structure, dimension, and code list. It has interfaced the Fusion Metadata Registry. So, indeed, this is everybody knows in the SDMS community what it is. So now some of the development I will just highlight. So we intended to cover around 90% of the banking business in India because so we have provided all the requisite information to the banks, and they are in the process of developing their own. There are certain changes because they have to come up with the infrastructure. Infrastructure is, I mean, there is no infrastructure is required, but they have to do some changes because they are already capturing the information which is needed for generating the reports. So they need to do some kind of tuning at their level. So that process is going on. It was quite successful. Many banks have done that. So now we are in a very confident position to execute this. So our plan was to execute in a pilot basis, I mean, in a phased manner. So probably the first phase we are targeting by December of this year. And very newly, when yesterday we were discussing about the NLQ tools and AI-based, so we are all because we made the foundation because SDMX is the backbone. So we made the foundation. Our system also SDMX is AI ready. So we are also planning to experiment with the AI NLQ tools, the natural language processing to this system. Thank you very much.
Thank you, Sujit. That was very efficient, rich, and dense. So we stay in a central bank now, moving to Indonesia. We'll talk about using SDMX in the context of quality assurance process. So I'm going to give the floor to, apologies if I don't pronounce your name very well, Sri Pujilistari and Mr. Koirul.
Yeah.
You know, you can correct my,
Okay.
the way I pronounce your name. So, the floor is yours.
Thank you. Good afternoon, everyone. Thank you for giving us this opportunity to share this work. My name is Muhammad Hairul Hidayat. I'm here with my colleague, Ms. Sri Pujilestari. We are pleased to present our project titled Advancing Statistical Quality Assurance with SDMX, a metadata-driven approach from consistency check to smarter dissemination in Bank Indonesia. I would also like to acknowledge another author of this work, Ms. Anggraini Wijanarti, Ms. Shandani, Mr. Ahmad Zaki, and Mr. Insan. Okay. Here's the outline, and there are 4 sections here. We will begin with the background. To begin with, let us set the context of our initiative. The strategic environment of Bank Indonesia is undergoing significant transformation, driving the demand for the data is more agile, comprehensive, granular, and collaborative, while ensuring proper governance as well. And we believe this phenomenon is not only happening in Bank Indonesia, but also in other institutions across the country. And on the legal basis, of course, we do the regulatory reform. And for our transformation program, we aim to establish cutting-edge digital transformation supported by integrated data information. To achieve that, of course, we need to digitalize our statistical business process. Here is the overview of our statistical transformation, guided by our data policy, promoting one input, one process, and 2 multi-purposes, and implementing the end-to-end digitalization encompass entire statistical business process, start from the data collection, and then input integration data to our Omni intelligent platform, and then digitalized processing, and also the digitalized of dissemination. And for the underpinning the all of the process, we do the strengthening overarching activities, which is involved revisiting statistical business process, and of course, we highlight in here metadata management and data quality assurance. So to enhance our overarching activities, one is we expect in the end step, we expect we will advance metadata management through the 3 key principles. First is metadata first approach, and then ensuring comprehensive and standardized metadata, and also integrated the metadata within our system to interoperability and integrated. However, at this point, we have to be honest that our current state, we feel that standardized is not fully implemented. So this is the reason why we initiate this pilot project to adopting the SDMX to build a metadata-driven quality assurance. So why do we need quality assurance? As you can see on the left side, we have Bank Indonesia manage more than the 50 statistical product and over the 1,000 indicator across the macroeconomic sector. To give you a sense, maybe one of our publication is Indonesia Economic and Financial Statistic, or we call SECI. More than 100 tables and attract over the 30,000 views per month. And also in regional, more than from the national level, we have a 34 province and with disseminate more than 200 tables. And other key products, including the financial system statistic and also the payment system statistic, which is wide coverage. We need to ensure the data quality, consistency, and also reliability before we publish to public. So that's why we have a pilot project, and we choose SECDA or regional economic financial statistic because there are so many tables there. We need to ensure the quality of each. So the process involved for stages. First is we prepare the concept scheme and code list based on SDMX, but we adjust to meet our needs, which is why we call that SDMX-like rather than a fully implemented SDMX. And we define the key rules, inter-table check, before and after, and also the inter-table, compare data between the related tables, since we disseminate several tables in each province with the different filter dimension and also with the same aggregate concept, so their consistency need to be verified. And also we do the automation with the Python's programming and job scheduler, and with the Power BI, we do develop the dashboard for the key area report. And for the execution, we finally running automatically with the job scheduler. And then how did it turn out? It will be present with Ms. Sri Bujulastar.
Okay, good afternoon, everyone. I will to continue this presentation. On this slide, we highlight the significant advantages of our new Python and SDMX-based approach compared to the traditional macro method. As you can see in the new system, over more than 93% improvement in processing time and provide for greater efficiency, flexibility, and scalability. For the macro Excel, need 3 days for processing time, and then efficiency declines as data or complexity grows, and then limited flexibility, hard to enforce standards across multiple files or user, and then basic integration. But with the Python and SDMX, just need 5 hours for processing time, high efficiency, highly flexible, follow SDMX standards, and high potential for interoperability. For the next, moving forward, our next pilot project, which focuses on leveraging SDMX together with AI-driven visualization. The primary goal is to make statistics not only consistent and standardized, but also accessibility, interactive, and actionable. On this top diagram, framework illustrate which is our end-state framework. On the end-to-end process of statistical product analyze and disseminate. For the begins on the left with our statistical product, which undergo metadata-driven processing that might based on metadata structure. And then the outputs are stored in a statistical database where we prepare multi-format output using dynamic templates. Moving further, the result fit into the analyze stage where statistical report, narrative, and insight are generated. And then the dissemination channels through in internal and external platform. Finally, the dissemination channel support various format. Okay, and then in the lower section on this slide, you can see the workflow of an AI-driven chatbot with represent our innovation in user interactive. Chatbot integrate to component database conversation and question conversation. For the database side, statistical analyze, statistical data, analyze report, and metadata are first converted into vector embedding. And then on the question side, user queries and are also converted into vector using natural language processing or a large language model. Which vector are matched through a similarity method, enabling the system to retrieve the most relevant statistic information. The retrieved information is then combined with a prompt template, and finally the response is generated by a large language model, ensuring the answer is not only accurate but also human-like and easy to understand. And then the last slide, conclusion and future work. Okay. Implementation of the 3 principles, the metadata first, comprehensive and standardized metadata, and integrated metadata. And then by adopting an SDMX-like standard to build metadata-driven QA tools, Bank Indonesia has reduced processing time from 3 working days to less than 5 hours. And then the development of AI-driven visualization platform supported by SDMX. And then the future work. future develop and then a future work development of data quality to include plausibility checks such as utilizing machine learning techniques for anomaly or outlier detection. And then extending output metadata standardized and developing QA rules directly aligned with metadata structure for other statistical publication. There be strengthened cross-publication interoperability. And the last, developing AI and SDMX-based chatbot will use standardized metadata publication to provide interactive access, enabling user to visualize and navigate statistical output more intuitively. Thank you.
Thank you very much for sharing so much information, not just on what is being done at Bank Indonesia, but also how it's being done. You all have the slides that you're, of course, invited to study in detail. Without transition, I'm going to give the floor to Marco Wilpsar. The presentation was supposed to be made by Jar Edding, who could not be here today, so thanks, Marco, for stepping in, who is going to talk about some modernization work of data dissemination at CBS Netherlands.
All right, thank you, and thank you for having us here. As you can see, I'm going to try to take you along a little bit on our journey to implement SDMX and .stat in our organization. As you can see, we are still sort of in the harbor, so safe space. People watching us. This represents both people internally in the organization, but also our partners that we provide a platform for with our current platform. And of course, there's the general public out there that is very interested in our figures, and they also need to be addressed, of course, with this implementation. Right. I didn't prepare an agenda here, but I'm going to talk you through a little bit of context. Where are we coming from? I'll focus a bit more on the organizational aspects, on the governance that is also quite important to have in place. And I will talk a little bit about tooling and the gaps that we identified in the tool sets that we put in place now, and we are in the progress of, we are in trying to fill those gaps by several initiatives. I'll come to that. So to provide a bit of context, we are talking about 6,500 data sets across about 20 statistical domains, and our current platform is called StatLine. It was developed in the 90s, way before I joined Statistical Netherlands. I joined only last year. Today this platform is end of life, and we are facing more and more difficulties to keep it up and running. So that and that was known for a few years already. So about 2, 3, or 4 years already, and actually way before people in the organization started to follow developments with SDMX. Then in the past 3 years or so, some more research was put into this, and then that led up to a decision mid-2024 to both adopt SDMX as the standard, and then as an additional decision to go with the FMR and .stat suite as our tooling to make this happen. Our legacy, so we're talking about, as I said, about 6,500 data sets or tables. We have both, about 1,500 of them are what we call them are alive tables, right? So these are the tables that are regularly updated with new data. We have lots of archive tables as well, and as you can see, also varying sizes. Most of them are quite small, but we also have some tables that are up to 1 billion data points. I think relatively large amount of rather big tables in our databases. About 300 are above, I think, 40, 50 million data points. And I'll come back to that because that caused some technical issues. So what did we do? After this decision was taken to go for SDMX and .stat, we started a program in October last year. Quite ambitious, actually. We thought we would be able to migrate and go live in a year. Now we are about a year further and we did not go live yet. So definitely some lessons learned and some challenges on our way. We started with representation in a core team, representation of all the statistical departments, but also our communication department is represented. We got technical representation, obviously. I'm working for business analysis and process modeling part of the organization. And yeah, also then to illustrate the importance for the organization, the steering group for our program consists of the directors of the 5 main divisions in the organization. Yeah, so because our current system is kind of technically out end of life, we focus a lot on automated migration, and actually that went quite well, except for one thing. It really tested the technical boundaries of the .start platform. So the main lesson learned there, yes, you can automate your migration. However, you do need to pay some attention to building in some quality in the results. What we actually did, we took every single table and created a set of artifacts for that single table. So you can imagine you end up with a lot of duplication in your system, and that caused the stress in the system in the end. Yeah, so apart from doing the technical stuff, we also put some effort in building a team to build the knowledge in the organization. So we have a very small team in the department where I'm working that is focusing on the SDMX, and yeah, we are developing training courses, and then we're a member of a wider support team, so that's more decentralized, because we think it's really important to have SDMX knowledge and modeling knowledge in the statistical departments, because in the end there is the domain knowledge on the tables that they develop, and that is we think quite important in their modeling effort. Yeah, some of the lessons learned compared to our current system, we already see that we will need far less people for designing tables, so that is I think that's good to see. Also already many times mentioned here, the need for harmonization, standardization of your code list especially, and the concepts in your concept scheme, that is well recognized also within our organization. Yeah, let me move on. A little bit about governance. So there's 2 things about it, I think, to mention here. So we did a redesign of our dissemination process, and the process and all its of its supporting tools obviously needs some governance. You need to handle, when the process needs to change, of course, you need funding for maintaining your tooling, etc. So that's one thing. But then when you talk about the data, especially then these code lists and concepts, yeah, we say this is actually not SDMX specific. This is, you need to do this whatever standard you use, right? Because this is about the definitions of your data in your organization, all the way from your import of your data towards your output, your dissemination of it. Your whole organization will benefit from harmonizing those concepts and code lists. So we, with regards to the data, we say, well, we do use this reference framework for governance from the SDMX community, but we tie this in, or we connect this actually to our organization-wide data strategy with regards to data governance. Then also we identified a couple of gaps that we need to fill. Because, yeah, as I was mentioning in the beginning, our existing tooling start line is well supported with also all kinds of additional tools to support the whole process, to do all kinds of validations, etc., etc. And yeah, moving to .start, not everything is in there, but of course the internal user expects the same level of support. So first of all, we identified, and I'm only going to highlight 3 of them, a tool to support the workflow and the process. So things to initiate a new table, or do a major change, or to capture all the approvals. That's the kind of functionality we look for in this tool. Then, as was mentioned actually earlier today by the colleagues of the World Bank, we also identified the need for a metadata management tool, because we recognize that the people that are typically going to provide this referential metadata are not the most technical savvy people in the organization. And well, I can tell you from my own experience, it is a bit of a technical experience to create that SDMX CSV file that contains the reference data. So, and we take that away with this metadata management tool. And then the last thing I want to mention about this is a more advanced functionality for maintaining and managing concepts and concept schemes. We do have another application in the organization to manage our code list. But we do not have a similar thing for our concepts and concept schemes. Now, of course, we do use FMR as a registry for all of that. But one of the ideas we have, preparing the organization to move from SDMX 2.1 to 3, you could already start modeling your measures as concepts, and then for using them in SDMX 2.1, you can automatically, or you provide functionality to create code lists out of these concepts. And then, of course, when you migrate to SDMX 3.0 or beyond, then you do not need to remodel all of your measures again. Some additional tooling, but you can look them up in the slides that will be shared later. To conclude, yeah, so we did have some issues with performance, especially because of the size of our data sets, because of the high number of duplication of artifacts. So we did recognize that as a problem, and we started to build in some quality, reducing the number of artifacts that we need for every table. We did some testing for with the to be released SDMX API, which looks promising. So that provided the program with a perspective to move on. Then, yeah, let me end with saying that, yeah, we established a support team. We established a technical team to support the whole technical infrastructure, and there is. There's still a way to go, but we think that we'll, towards the end of the year, we will be in a let's say, a bit of a safe harbor, and we know that we can go on and implement this and go live next year. Thank you for that.
Thank you very much, Marco, for this honest reporting on your challenge, and for mentioning that I think you're the first one who have managed to reach the limit of .stat. So I'm sure that Jens and Eric here have probably already addressed that. That's the beauty of having a lot of people using a tool like that. It will keep, for sure, improving constantly. The next speaker will talk about VTL. I heard yesterday that there was a lot of interest in VTL, so the next 2 presentations will actually be related to it. So this is Glenn Tice from BIS and Antonio Oleros, who are going to talk about simple, scalable, and agile VTL execution using FMR and open source Python package. The floor is yours.
Yeah, perfect, thank you. So yes, as builds, then we're going to look at this question of how we can improve business processes, and specifically about VTL execution, and specifically how we can make it a bit more simple, scalable, and agile using some open source tools. So immediately I'm going to hand over to Antonio to kick us off. Antonio, please.
Thank you, Glenn, and good afternoon. I want to start actually by taking a question from yesterday. It was from this area. I don't know whether people have changed, but it's your question, okay. Which was whether it was VTL was production ready, right? I think it is a relevant question. I have a clear answer. Yes, it is. Or some products, right, for VTL are production ready. But I think that the message we want to share today is that it's beyond there. Because VTL being production ready means that an institution can use it and can use it effectively, right? But the nice thing about VTL is that it also makes the statistical process simpler for other institutions, right? So a lot of the institutions that are around share the same characteristic, right? That is that you have stakeholders. You collect information from other organizations. And this is what VTL is simplifying a lot, especially now when there are mature open source tools. And this is what we are going to present. I'm going to go with the simple part, and then Glenn will deal with the scalable and agile. So I love talking about VTL, but today, unfortunately, I'm not able. I'm just able to say that because we don't have time. So I'm just able to say that VTL provides a powerful language for data validation and transformation. You'll have to take my word on this, but I'm very happy to discuss this if you want. But that's not enough. If we only had VTL, like we have had for some time, we would be missing something, and it is about tools. And now we have some tools, some commercial tools, but we also have some open source solutions, right? And what we are going to show is that by using this combination of 3 tools, 2 Python libraries, the VTL engine and PySDMX, and the Fusion metadata registry, we are able to deal very effectively with the VTL. So I'm going to show some code, but we believe this is so simple that it is not going to be problematic. Even if you have never used Python, I think you will be able to understand what we have to say. The Python VTL engine, this is one of the open source libraries. What it's doing is making it easier to execute VTL, okay? First, we have to say something like, we want to use the VTL engine, right? And basically, when we want to run VTL, we need 2 things. We need the script that we want to run and the input data, right? This is VTL. This is a very simple thing. The only thing it's saying is take one data set that is called DS1 and multiply it times 10, right? The second thing we need is the data. This being an SDMX conference, I guess it's not a surprise to anyone that for data we need 2 things. We need the data structure and we need the data points, right? Originally, we support some format in the VTL engine library that you can write the data structures and the data points, okay? And the only thing we have to do is run this script with this input data, right? I think it is simple enough. And what we are getting as output, as of today, is pandas data frames, right? That is the result of executing any kind of VTL, not only this simple one, but also more complex VTL, okay? But there are a couple of things wrong here, and I'm going to go for the first one. You see there's no SDMX around, right? Which somehow it means that we are duplicating efforts, because most likely we have the data structures and we have the data points already in SDMX. That's the good thing. VTL engine is now SDMX native. That someone said this morning that it was a new word. We had it before, so. And this is the case because we also have PySDMX. And PySDMX and VTL engine, they work very well together, okay? We can use it, of course, PySDMX for both data and metadata. So now what we will have is, okay, the VTL engine, PySDMX, we have the script, but now we can link to SDMX REST API for data and metadata, and we can run based on the SDMX part. And we would get still the result. And I will leave the floor now to Glenn to see how this can scale.
Perfect. So yes, absolutely. This whole package of PySDMX and VTL engines sort of makes the whole process of executing VTL now really simple. I mean, as you've seen, it's literally just one line of code, run VTL or run SDMX. But I guess for production use cases, we need something more. And specifically, we need a way to package and distribute VTL. And actually, we already have some good ways to do that. And in fact, the SDMX information model, if you sort of delve into the depths of it, actually has this thing called a transformation scheme. I think it was mentioned possibly 1 or 2 times in sort of previous presentations, maybe yesterday. So these things are fairly sort of involved structures. But I think, you know, there's really sort of one takeaway here that a transformation scheme in SDMX is a VTL script, it's a VTL program. So if you remember that, forget about all of the complexity behind it. Transformation scheme is a VTL script. And the key innovation here is that this is now supported natively by SDMX and VTL engine. So it wasn't shown in the previous code, but you can do this. You can now pull a transformation scheme, in other words, a VTL script, directly from a registry or even from a file as a transformation scheme, and you can execute that directly. So that's really helpful. So that allows us to do sort of several things here, and particularly, of course, sort of packaging this together as packaging as a transformation scheme, and then using maybe FMR as the repository for this means the business logic can now be decoupled from the data processing mechanics. And it's this separation of concerns that actually makes the data operations more scalable. Particularly, of course, the business rules and data structures, these can now be reused across multiple processes. Why? Well, because it reduces duplication and, importantly, actually promotes modular and composable data pipelines. So there's benefits here both for sort of internal processes. So if you're working with data pipelines internally, then it improves that process by reducing this duplication and composable pipelines. But also with the external data collection use case as well, we have some real benefits there, because it means now that external data providers can now use VTL engine by SDMX, as we've just shown very simply, to carry out their programmatic checks using the data collectors, using your business rules before submission, and that guarantees integrity and also eliminates the propagation of bad data and the cost of fixing those errors sort of later on down the pipeline. And all of this sort of makes our processes nice and scalable. But there is more as well, and again, because the business logic is separated from the processing mechanics, these two can now evolve separately, and particularly and importantly, now business users can now properly take control of their business logics. It's no longer embedded in code within pipelines, and that means these things can iterate rapidly. Business users can change code lists, they can modify the data structures, etc., as need, without making any pipeline changes. And that relieves the burden on, of course, on IT specialists and data engineers, and I'm sure they're going to be all very pleased about that. And of course, the net effect of this is that we end up making the whole data operations more agile. So just to conclude, VTL engine democratizes VTL. PySDMX, as Antonio showed, works very nicely with VTL engine. Now it's VTL work very nicely in the SDMX context. FMR productionizes the whole thing. We combine all of these together, and then we end up with a really nice package for simple, scalable, and agile VTL execution. And it's all open source as well. So that's all. Just one thing before we go. Check out the references in the slide deck when you get access to it. There's links to all the tools. And also a really nice, fully worked example that Antonio put together as a Jupyter notebook. So thanks so much, Adib. That's all, folks.
Thank you very much for this very practical presentation. So if you don't know Python, I think it's time to start learning it. We probably have time for 2 or 3 burning questions. I want to be sure that we don't steal time from the presenters of the next round. So we're going to take 2 or 3, not many more. So Abdullah, then do we have running microphones?
Yeah.
Yeah. The other side, Abdullah.
Thank you. Thanks very much. My question is to Marco. Can you say a few words about the link between your production units and your dissemination units? How does the data flow? and if there are any plans to introduce any automation into that part as well, or there are no plans. Thank you.
Before you answer, we'll take the other question. It was there.
Yes.
And then there, and then, I mean, 3 questions. That's
Question
what we'll start
related
with.
to VTL. Okay, I am not an expert of VTL, so maybe I haven't understood very well. But my dream is to receive, for validation, from the international organization where I have to report my data, a validation message. You mean this when you speak about transformation schema? So that under the transformation schema, there is an SDMX message with the validation rules. And in this case, could you please share somewhere example of this validation message compliant with the SDMX transformation schema? Thank you.
Then we had a third question, and then we'll have short answers.
I'm Vladimir for Unido Statistics, and I have a question to Reserve Bank of India, Sajesh. Yesterday you questioned about experience in training a model, and you got no answer. I see today that you are playing with AI models or LLMs, and do you have any experience with supervised fine-tuning and reinforcement fine-tuning of pre-trained LLM models?
Okay, thank you for the questions. Marco, maybe you start,
Yeah.
then Glenn, and then Sujesh.
Yeah, thanks for the question. We believe that the ownership of the data, the content of the tables is really with the statistical departments. And so they own the table, they own the table design, but that is of course guided by SDMX guidelines, modeling guidelines, but as well as SDMX presentation guidelines for presenting or disseminating it through our output channels. So it's really an interaction between our communication department and the statistical divisions. Does that answer your question?
Do you use any standards for any process system going from microdata to dissemination?
Well, that's work in progress. So I think, well, I'm not working in this field for too long, but I think from what I've learned so far, in many organizations, the processing of the data from microdata all the way to the aggregates and the tables that we disseminate is usually with the statistical domains, and they maintain, in our organization, many of them maintain their own systems. There is, with the establishment of the dissemination process and using SDMX, then of course the SDMX model, table model, provides the specification of the data that you need to provide to the system. And then we expect, but that's really for a phase 2 in the program, that we will see more automation in the processing from microdata towards this dissemination system. Yeah.
So the question you were asking, because yesterday I was asking this question because we have just started this project. We are not even, I mean, this is very nascent stage. We are ready with the AI. I mean, the SDMX backbone we have developed. So if we query anything, so from the SDMS dimension code list, data can be retrieved. But the question is like, suppose RBI or any of the central bank, so the public trust is very important. How, because the credibility. Suppose even ChatGPT, we have different AI tools. People can generally ask any number of questions, so they will give answer. But the question is like, suppose RBI or any institution publish a data through their data portal in a specific written format, so people have trust on it. But if you are asking through AI, if the answer is not exactly the answer what it is intended to be given, then there's a question of credibility. So how to train, how to convert this question into proper, how to code this question, convert into proper question, and the system, how the model has to identify. That is something challenging part. So that we need to address. So that's why I was asking question yesterday, if somebody has experience, how they trained. Yeah, that's all. Otherwise, we are on the very, very initial stage, so it's a learning process. Yeah, thank you.
So from the VTL part, yes, that's exactly it. And I would say it is even nicer, right? Because if you have an FMR instance, then it is there. You don't even have to provide anything. You can also check by references because there is a mapping, so you can even see any user that has access can check what are the transformation schemes related to this. So in practice, what are the validations that are related to this? So once you have it in FMR, it's public for everyone's consumption and everyone's execution, right? So that enables any stakeholder to run what you have written. And we have an example in our repository. It is used in the Jupyter notebooks that was in the resources, but we can share it with you.
Thank you. We're going to now to reboot the table here. Try to be efficient and do that in 1 minute. So thank you very much to the 4 teams. Anywhere you want. So that was very efficient. We're going to move to the next presentation, which is, again, about VTL. There seems to be much appetite for that. And Violetta Kalian, I don't know how you pronounce your name, sorry, from Statistics Ireland will present open source data validation, integrating SDMX, Python, again, VTL, and machine learning. So, floor is yours.
Thank you. Oh, is it sound is good? Is the sound okay? Yes, this is, the title is a bit long, and I think when we gave this title to start with was just to remind ourselves what we want to do. So we were afraid to forget something and put all the things in it. I will not focus on VTL, but it's there and it plays a role. So this is the work of two very different people from Statistics Iceland. I'm a mathematical statistician and a methodologist. And my colleague Ragnhildur, she is an IT specialist, and she's much more knowledgeable than me about SDMX. But I was much more concerned about one of the processes that takes place in an official statistics institute, which is data validation, and which we think should take place in many places throughout production. So it should not take place once when you get your data or once when you deliver your data, but it should take place in many steps throughout the whole process from the start to the end. And this was our goal, to do open source implementation. We are a small institute and we use open source as much as possible, so knowledge that others share, and we like to share what we can do also with the others. And we try to take advantage of several things. SDMX is one of them, like many other people around here. But also machine and deep learners, I'm not saying AI, but deep learners, just nice neural networks when it's needed. And of course using languages like R, Python, and of course VTL, now becoming much more easy due to Python, in fact. So the principle is, if you want to do data validation in many instances for many data sets, normally this is not a very well-defined thing, because the data validation is confronting the data with a set of demands, put it simply. And then it means that this confrontation is data dependent. And you don't want to create a set of confrontations for each data that you might encounter in production on throughout. So what do you do then? You create 60,000 data validation sets of rules. How do you do that, and who's going to do that? And the idea behind our work was that we can use a unique method. We cannot use a unique set of rules, but a unique method, which can be highly automated in addition. And this, I think, is what we bring new to this table. We can have then multiple sources of validation rules for any data set, for any data instance, wherever we are in the production process. And we can do that in several ways, which you will see in a moment. So, and in addition to validation rules, we can use more interesting, quotation marks, methods like hunting for anomalous data points to check if something wrong is going on in the data. And also find significant association rules from the data, because you start from the idea that most of your data is okay. Just some of the records or some of the fields will have some errors. So then it means you can learn from itself, automatically, of course. And yeah, as I said, using open source code. So this is a representation. I hope you see something here. Yeah, better than me on the screen. Okay. So this is a representation of the fact that I was describing, that at each of these stages, like sourcing or analysis or dissemination or staging, all these steps throughout a data life point, you have to do, in principle, a validation to create a trustable quality end result. And you don't want to start with the bad data. You have to first check whether you are getting what you thought you are getting. And that at different stages, you want to make sure that you are starting your analysis or your staging with what you thought you start with. And of course, you don't disseminate without checking carefully. And this means, for example, this confrontation or hunting for anomalies, that means you need these rules at each stage. That also means that once you manage to collect these rules in a unique way, but with many, many results, you have to keep an eye on the rules themselves, how they flow, how to manage them, where to put them in a database, obviously, we think, and then, of course, to do this confrontation. And here is the grand picture in a simplified way, actually. So you have many sources for your rules. You can have manuals and documents from Eurostat, because, well, we all have to deliver something there. But you also have a grand source, which is the SDMX registry. And you have the data structure and the code lists, and those will tell you everything you need, more or less, about how your data should look like. You might need to map things if you apply this, the rules you extract from the data structure and from the code list. You might need to map them to the actual state of your data. Maybe the names of your variables are different, and so on. But that's details. Let's not worry about that. You might have expert rules. The people in the domain, statistical domains, have very strong opinions and very strong knowledge that might impose some rules. And okay, yeah, the data itself, because I said you will do discovery of association rules or discovery of anomalies in it. And you have many methods to do that. I don't have to teach you that. And most importantly, nice tools, which are open source in R. And you heard already about VTL engine and R SDMX. Some grant packages which we like from Statistics Netherlands, which are validate and validate suggest packages, and that some A rules and some maybe deep learners for finding anomalies. So Python or R are the languages of choice. This is a picture where you see the tools in action more, depending on what the source is, and you see exactly what kind of tool you might. We made a proof of principle, and we tried all these things, and we shared them on our GitHub that is mentioned on one of the slides as exercises and snippets of code. Code is very simple. Here is the database rules that some technical expert like my colleague is in charge with. This is just a vague picture of it. Of course, it's much more complex than that because you have to keep track of what they are, what the rules are, give them some IDs, where are they from, and all kinds of other attributes about each of them. So you must be careful about that. You might be extra careful and even hope to add disclosure control rules if you are ambitious. This might be a direction. Here are some simple codes, again, showing, like our colleagues before, that just a few lines of code can solve a lot for you, very few. And yeah, that's it.
Thank you so much for this other very convincing presentation on VTL. I think it's good advocacy for the solution. It's good advocacy also for Python and the open sourcing of solutions. I think organizations that put the solution into package and libraries deserve a lot of credit for that when they publish that on GitHub, so thank you. Next presentation is by Daniele. Yep. You have the... So Daniele Olivotti from UNICEF, talking about driving automation with SDMX and UNICEF State of the World Children's Statistical Compendium.
Okay, good afternoon. Today I would like to present how we use the SDMX to create publishable report that can be printed and can be disseminated. In particular, I will focus on the State of the World Children, that is the UNICEF flagship publication that contains important indicators on the situation of children around the world. It contains 23 tables of data, around 200 indicators, more than 200 countries and regions. So this means a lot of data that needs to be, of course, correct, and needs to be consistent, correct, and ready to be published and seen by policymakers, researchers, and the public. How was the process in the past? You can guess it. Excel was involved in the process. So indicators were manually extracted from different data sources, copied and pasted in an Excel template, and then handed over to designers that were copying and pasting again in design software like InDesign. So each step, each copy and paste can introduce errors, and you can imagine, let's say, new indicators were updated, new data were coming from the countries, another round of emails, another round of copy and paste, and I was actually surprised that the amount of errors was very low, so good work from my colleagues that checking every step. Okay, the role of SDMX, how we made it better using SDMX. Our SDMX is always up to date, so we have the latest. We are sure that the latest data is available in SDMX. It's the single source of truth for our data. And let's say that State of the World Children, the publication of State of the World Children is just one of the many possible outputs that we can have with SDMX. We can publish in dashboards, we can publish in websites, we can publish in applications and so on. The process now, we have a configuration file that just maps an API call, so we can say, give me this data set, it is mapped to a single column of the publication, as you can see in the screenshot. Data is pulled from the SDMX API, and the output is already a PDF format, so no more design involved, no more copying and pasted. If a new dataset comes in, we just hit a button again, and we regenerate the full publication. So no manual work and reduced error. This is an example, the API call. We're asking the registry, okay, give me child mortality, under 5 mortality rate for Afghanistan, male, in 2021, and it is just put in the, of course, sorted and put in the column. But with minimal effort, we can produce a lot of other reports. So, for example, State of the African Children, similar publication, just focused on the situation in Africa. So we are focusing on countries in Africa and aggregates, regional aggregates that are important for the African countries. And we just need, to change images, the narrative, and the configuration files. Again, we hit a button and we have the publication. In summary, important, SDMX is our single source of truth. We are applying the COPE principle, so we create once, we put the data once in our registry, and we publish through different channels. Automation is important, it reduces errors, improves reproducibility. So if we spot an error in the publication, we are sure that the error was or in the source data, very unlikely to be in the process. Efficiency, one click, we publish the data. Imagine the data that was lost in all the email exchanges, copying and pasting, checking. Reusability, we can reuse the same backbone for other reports, and we can easily produce multi-language output. And that's all, thank you.
Thank you so much, Daniele. That was brief and very, very convincing as well, I think. A lot of us are still relying a lot on printed publication for disseminating data, and that will stay for many years. So saying that SDMX can automate this painful process is good news for everyone. So thanks a lot for that. We're now moving to a presentation by Truckstat. So the presentation will be about the journey end-to-end implementation for local needs. So I guess it will cover the whole data lifecycle in your organization by Ezgi Sena Ertur, sorry, I'm trying, and Junaid Kurt. So I don't know who starts. You have 10 minutes together. Thank you.
Thank you. Today we will talk about our journey of SDMX. My name is Junaid Kurt, and here my colleague Ezgi Sena Ertürk. First of all, we will start our motivation, why we choose SDMX paths, why we start this project. At first, we need a dissemination system. We have nearly 15-year dissemination backbone, and we need to refresh it. Also, we have a lot of demands of data for researchers, or they need web services, they need data in different formats. And we choose the SDMX path for these reasons. SDMX brings you a database structure, standardized database structure. You don't need to think about how these tables will be, how this process will be. Also, SDMX gives you web services. SDMX RI gives you web services for disseminate your data to machine, to other stat units. And latest nearly 5 or 4 years, SDMX gives you browsers, data browsers, data explorer. It is very very plus for choosing SDMX. And we choose for these reasons. At start, in Turkstat, we have some standardized projects. For example, Arzemli is our data collection platform. Uses DDI for generating data collecting programs. This Harzemli project gives us a vision of standardizing elements are good. We should standardize all of GSPPM phases. In Turkstat, also at initial state, we are using SDMX, but every unit using different SDMX things. For example, some of them using Excel, some of them changing their SDMX manually with Notepad or something. But one unit do something, other units don't know the phases, the parts. Why we did a new system? I told that that brings common language, transparency, reliability. It's efficiency and speed, and we are software developers. It brings us more speed for data software developing at these phases. If we don't use the SDMXRI, we have to develop new systems for just disseminating our data. And global alignment is Turkstat always based on standards, but you have to do extra effort to get these standards. So this path will be our standards. We try to standards first approach. We move step by step. We don't use a solution of package. We have our unique institutional fits, and we developed some approaches for this. This is a simple vision of our system. We have DMAS is our metadata editor. We write the code of STEM. It's like SDMX Toolkit's MDM, Istat MDM. We have also Pusula. Pusula is our data preparation and validation application. It can use SAS, R, or some other data processing language. We use data browser. We use Istat's data browser for this time. We change its front end, but we use the data browser software at backend. And SDMXRI is all of the backbone of all of the processes. Sena will continue in detail.
Hello. DMAS is our main system for metadata definition. It is inspired by Istat Toolkit, and we basically use the same data structure with Istat Toolkit, but we changed its interface and created service layers from the storage. We wanted to have a flexible structure because in Turkstat we use an approval application nearly for all of our applications, and we also have role-based validation. So we wanted to have a flexible system so we can easily adapt this to our system. With DMAS, we can basically create conceptions, DSDs, mappings, and data flows. We have also another application. Pusula is already used by our producer departments. They use it to do some database operations, and also they can use it for data analysis, process data, tracking logs, and another operations similar to this. So we thought that in this way, by using Pusula, we can reduce the developer workload. And also our producer departments are familiar with the interfaces of Pusula. We add 2 steps, which is related with the SDMX, and they can validate their data. Once they create their metadata in the MES, they can map their data set. So they can validate if their data is suitable for Codeless or not. These 2 steps are automated by Pusula. And we have also another process, and it is to transfer our data to the SDMX database. And after completed these steps, they can move to another step. After validating our data, we can transfer to the publication step. Actually, to visualize our data, we use Data Browser. It is an open source tool from ISTAT. We changed its interface a little bit according to our institutional needs. So we thought that it could be more user-friendly for our producer departments. And we also installed and tested .stat suite and Stat toolkit at the same time. And we examined and tested both of them, but we realized that it could be easier for us to adapt Stat toolkit to our system. So we wanted to go with it. And there were some challenges that we faced during this project. For example, it was more like trial and error for us. We had some difficulties because we need to learn everything from the scratch, from the beginning. So we took some courses, and also there are some colleagues that help us a lot to move. They were from ILO, OECD, and StatSuite, and ISTAT. And also relying on Excel was not sustainable for us, so we wanted to have a direct database-driven integration by using Pusula. So our next step, now we can say that in Turkstat we have end-to-end SDMX system, and we have fully integrated, sustainable, and automated system. And we also published some statistics by using our new SDMX system. Right now, we can say that we have at least 60 data flow that are defined. And our next step is to move our old data dissemination system MEDAS to our new system. Step by step, we are planning to support our producer departments to move their data. And also we are currently working on another application, which is a web portal. And we are planning to use it to show our data, which we published in our new SDMX system. And we hope our experience can serve as a model for the countries with the same need. Thank you for listening and for your support.
Thank you very much. That sounds like a lot of software development in-house. So congratulations for that. Now we're going to move to the last but not least presentation by Kun Thidaratnan Singh about modernization and automation of pipelines within NSO in Thailand.
Okay, thank you so much. Good afternoon, everyone, ladies and gentlemen. It is a great pleasure to be here in Rome, Italy. Today I will present about modernized statistical processes with SDMX compliant automated pipeline. It's just Thailand NSO case. Oh, I forgot to. My name is Thidaratnan Singh from Bangkok, Thailand. In this presentation, I will cover main topics for background of work on SDMX in Thailand NSO. Next, some use case and success story, where explain where SDMX find in the why we decide to develop. Finally, we will share about the conclusion and next step. You can see that TNSO SDMX journey we have began in 2011. we interesting to exchange data among government in Thailand. And later in 2013, we develop our interesting, SDMX. We have training by Abdullah from UNSD. Thank you so much. At that time, we could export our MDG data via SDMX API. Since then, Thailand NSO had actively promoted adoption of SDMX standard. Building on this foundation, we expand our role as central agency responsible for integrating and consolidating statistical data from government bodies across the country. Our goal has always been prepare and disseminate data according to SDMX standard. Since 2023, we reached a major milestone with the government data catalog. The system integrates data from over 200 of government agencies nationwide, consolidating it into centralized platform using CCAN. The data is then disseminated according to SDMX standard through our statistical sharing hub. In 2024, we launched a data integration project that significantly improved our internal processes, especially in data collection and data preparing that I will show in our next slide. This slide as we continue for our SDMX journey, this image highlights several key moments of our collaboration and learning over the years. Each photo represents a step in our continuous effort to improve Thailand NSO staff in line with workshop and training capacity building both domestically and internationally. You can see the management provide support for us to compiling data in accordance with SDMX standards and acknowledge the advantages of SDMX in our office. About use case and success story, our past use case success story including actively adopting SDMX standard by developing key IT tool. I use a website from sdmx.org for educate and building SDMX compliant data interface, training staff, and migration legacy datasets categorized by international indicator. Now we're covering 21 statistical sector and area into standardized formats, which are now public and accessible via Statistics Sharing Hub. You can see the website. Now let's look at our current workflow at the challenge we face in implement SDMX. For this SDMX state in Thailand NSO, we taking several key steps, just calling data from government data catalog platform, create data structure, definition, and preparing data according to SDMX standard. Even this effort, we still encounter several obstacles. Currently, there is no unified system for SDMX file preparation, and much of our workflow rely on manual processing. In short, manual processing diverse data format and gap in automation create heavy workload and slow down update. To overcome this issue, we launched the data integration project aiming to transform the entry process into automated SDMX. This project aims to create sentence service for convert data from unstructured source file and into machine readable structured file, and to create data visualization service with various graph format to display data, and to create a system for collecting statistical using automated tool. You can see the solution deployment and deliver of data integration project. This slide shows overall picture that how we have used to form the data integration project to prepare our data in line with SDMX standard. It illustrates how each step is connected, making the whole process more consistent and streamlined. I show about the pipeline step in our system in the data integration. We just have used the data integration technology such as we have data source, diverse official statistic input, and automate with RPA and Airby connector, and transforming we use DBT map to SDMX CSV standard. And after that, the Dexter schedule and automate task. And then we export standardized data share to statistic sharing hub for dissemination. Our challenge, I think it's not up this slide, but it was okay. Data source diversity is the challenge of us. We rely for multiple source which make consolidation difficult. Limited automation, only few tools current, and we have to decrease pipeline gap using data integration. About the conclusion, we have the modernized statistical workflow across government, enhance accessibility, reliability, and automation aligned with SDMX standard, and support integrate policy making and dissemination. Also, we plan to expand role for AI data validation, report check, and expanded AI analytics. This brings me to the end of my presentation. I hope this insight for you. Thank you very much for your attention.
Thank you very, very much. Maybe we can take 1, 2, 3 burning questions. The questions that are not burning, keep them for the tea, coffee time. That will happen in 5 minutes ago. Louis? Yeah.
Okay, thank you. You can hear me? I'm Luis Koku, African Development Bank. I have a burning question for Daniel, UNICEF. I really like your presentation. I want to know the publication. You managed to publish that without any graphic designer? You manage yourself text, photo, table, and chart? I want this confirmation. Thank you.
Is there any other burning question? Okay, then it's all to you, Daniela, and then coffee and tea.
Okay, thank you. So the publication was created by designers since the beginning. The State of the World Children has been around for several years. What we did actually was to take what has been done by the designer, replicate the design. So we knew that in this position there is an image, the table has like, say, 10 columns, and we replicated everything in a Python script. So the Python script is actually, when you hit the button, it's creating the PDF template, injecting the values in the columns. So yes, at the moment the publication is, we don't pass through any designer anymore. We just change the images, point the configuration file to the new images, and everything is done without but we used a previous version of so there was some designer in the past. Now there is no one involved anymore.
Thank you, Daniele. I'm sure that this answers your questions, Luis, and satisfies you fully. So thank you very much for your attention, participation, and thank you again to the 8 teams who presented.